Okay. Hopefully it's recording. I wish I could see it, but it doesn't really tell me. It is recording. How do I go back? Okay. Um. Okay. Take it from the top, I guess. So for the points P and Q, find the distance between P and Q. So P, it's saying from P to Q. So this is going to be our point one, point two, or x1, y1, x2, y2, right? Um, Simplest case, you're just gonna have to memorize this equation. It comes from the slope, which is m equals rise over run, which is y2 minus y1 over x2 minus x1. It comes from this and also comes from the Pythagorean theorem. That's going to complicate it too much, so I think your best scenario here is to just oh man, all right, whatever. Is just to memorize this formula, which of course would be x2 minus x1 would be -1 minus 6. So it'd be -1 minus 6 squared plus -3 minus 5. Which would be -7, -8 squared, 49 plus 64, which is root 113, right there. Find the center radius form of equation of the circle. So again, this is another, you're just gonna have to memorize this formula, but if you do that, these are pretty simple. If you have the center, which in this case it's -5, -8, and you have the radius, which is r, then you could just plug those into the equation of a circle. So our x is going to be our h value, our y is going to be our k, and of r is of course going to be our r, and you plug that back into here. So it's going to be x minus h, which is -5, so it's minus -5, y minus a -8, and then r is going to be 8, so r squared, which of course is 64. Negative, negative, that's positive. Negative, negative, that's positive. Which one matches? And this is going to be 64. So what matches this one? It's going to be this one right here. All right. Same thing for this one. We need to find the equation that represents a circle. We need the center point and its radius. The radius, again, is, or not again, but the radius is half the distance of a circle. So from the middle to one of the walls, in this case, our radius, or let's start with the center point. Center point is this one right here, which is at, this is -1. This was at -1, or this is, fuck. This is at 1, this is at -1, so the center has to be at 1, -1, right? That's the x and y coordinate of this point right here. And the radius is 1, 2. It's 2 units, so r equals 2. And then we just plug it back into the circle equation, which again is x minus h squared plus x, or y minus k squared equals r squared. Plug the h in, which is x minus 1 squared plus y minus -1 squared equals 2 squared, right? Because r is 2, that's where that comes from. Our k is -1, that's where this comes from. and our h is 1. That's where this comes from. Which, of course, is x minus 1 squared plus y plus 1 squared equals 4, which is this one. Decide whether the relation defines a function. I think you put it here. For every x value has one value, right? So each x value here has its own value, right? And so each y value has its own value, right? So blah, 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 blah. So this one would be a function, but this wouldn't because it has two of the same x values, right? Or another way, 3 is both equal to -4 and, or not equal to, but like, I think you get it. 3 is both -4 and 2, so this is not a function. Yeah. All right. And then for graphs, to define if it's a function or not, you do the vertical line test. The vertical line test is you put a straight line through your function, I guess. And if it only passes through once, then it is. If it passes through twice or more, it's not. So for this one, if I put a straight line through anywhere through this line, if it only hits one, then it is a function, which if I would put it like right here, it only hits this spot right here. So it is a function. For this this is not a parabola, but whatever. Parabola is this. This is a parabola. This is an ellipsoid. But for this one, if I put a straight line through, let's say this point right here, it hits here and here, so it is not a function. Give the domain and range of the relations. This one, you're just setting up the domain, which is the x-axis, and the range, which is the y-axis, and from smallest to biggest. So for the domain, it'd be -6, then -3, 2, then 4. It'd be this one, but we could just take it one step further. For the range, it would be -8, -8, -5, and 9, which you wouldn't put -8 twice, so it'd be -8, -5, 9, which is that one. Which right here it says order the numbers, which is pretty much what you're doing. Decide whether the relation defines a function. This one is similarly to this one, where it can only have one x value for each y value. It's kind of the same thing here. This is a straight line, so for any x value I put here, it's going to have a different y value regardless, right? It's a linear function. You can kind of see what you did here, where you're like, at 0, it's -4, at 1, it's -2, at 2, it's 0. So you have different numbers. This one is kind of like you have to conceptualize it a bit, but this would be a function. If you want to look at it right here, if I have like a linear function, like 3x plus 2 or something like that, let me do this. For any x value I put in, it's going to give me a different y value, right? So if I put in 2.93 as my x, it's going to spit out 10.79. That 10.79 is never going to pop again in this line if I choose a different x value. All right. So that is a function. But for this one, y squared equals 3x. If I get rid of the square and put a square root, so y equals root 3x. What is it? So remember, for the square root, when you give an answer, it's y equals plus or minus 3x. So that means at positive 3x, you get this y value. And at negative 3x, you also get the same y value. There's a repeat. And you can't have a repeat. Therefore, this is not a function. Yeah. Give the domain array and range of the relation. Remember, domain is x, this is y. So domain, you could see right here, this will be 6. If you don't know that, this is, if you see a 10 right here, um, there's 1, 2, 3, 4, 5. There's 5 spaces. That means it goes in increments of 2. So it goes 1, 2, 3, 4, 5. Or, my dumbass. 2, 4, 6, 8, 10, which is 10 right here. Okay. So we know this is 6. We could see that the line of this parabola reaches at 6 in the x direction. So this is the lowest number it could be. It's at 6. So I'll put, and it touches it too, so it's going to be a bracket, 6. This parabola is going to continue infinitely off page. It's going to keep going that way. Therefore, if it keeps going that way, it's infinitely going towards the positive x direction. Therefore, it's going to go here, and it's never going to touch infinity, so it's going to be a curved bracket. So this is the domain. The range is a bit different. If I start from here, and it's infinitely going this way and that way, that means it's slowly reaching downward and upward. And so slowly it will creep towards positive infinity and negative infinity in the y direction. So it's slowly going up in both directions. Therefore, the range is going to be negative infinity, infinity, which is that one. Okay, so for domain or range, it matters where the line touches, not necessarily where the dots are, but wherever the line touches. So for our domain, let's start with that one. The farthest point our line touches is this point and this point. And since they're black dots, that means it hits it. If it's circle, that means it reaches but never touches. And so if it was a circle, you would put the curly bracket instead of the hard bracket. So this is our domain. This is the farthest point it reaches on the x-axis. So this is -3, and this is 0 on here. So our domain is -3, comma 0. So D is -3, 0. Our range, do this, similarly, is farthest point it reaches in the y direction, in both directions. So it's going to be this +2 right here, but it's also going to be this little this little crevice right here, right? Because the line does touch this -2, as you can see there. So that means our range is going to be -2, 2. And it does touch, so it'd be that, which is, of course, that. X equals y squared. So x squared, or y equals x squared, is this graph. It's a parabola, or that one. However, let me do purple now. X equals y squared is that same parabola, but it falls over, and it's like that. Okay. You could probably see it right. X, get rid of that, equals y squared. And it's that same parabola, just kind of fell down. And it goes towards infinity. So on that same, and right here it shows like a bit flat. But if I were to stretch it out a bit, it does slowly get bigger and bigger. Okay. So, with that being said, we're focusing on the purple one. It's this one right here. It hits the origin. This part is its domain, and it goes towards infinity that way. So it's going to be 0, comma infinity for its domain, and its range is similarly to this top one, where it goes it slowly goes up and down in both directions. So it's going to be negative infinity, positive infinity, which is blah. Da, da, da. Get rid of that. There we go. Okay. For y equals 7 plus x, an important thing you would want to know is that in your cases, you never want a negative in a square root because that deals with imaginary, and you personally don't want to deal with that. So always try to keep what's ever in here positive or 0. That being said, so y equals root 7 plus x. What number that can I plug in for x that ensures that this is 0 or higher? Well, you could take this out and make an equation. So 0 is the lowest number you want, so set it equals 0. And of course, x equals negative 7, right? So any number that is lower than negative 7, like negative 8, negative 9, negative 10, those numbers are going to give you a negative in here, which is imaginary. And so any x value that is greater than or equal to negative 7 are good. Therefore, our domain is negative 7. That's our lowest x value we could go. And it goes towards infinity. Right? And we kind of don't got to worry about the range because the only one that fits this one is domain negative 7 infinity. And you're probably wondering, why did you guess infinity? Well, because any number higher than negative 7, right? Let's say it's negative 6. This is positive. I can make this a billion and it's still positive, which is still fine. As long as anything under the square root isn't negative, we're good. So anything below negative 7, we're messed up, right? If it was negative 7.1, that'd be still negative. That's messed up. Evaluate the function, find f of negative 1 when f of x. Okay, so I wrote right here, plug and chug. So when you see an f of negative 1, all that's saying is whatever inside this parentheses, you plug that into the function right here, right? So in this case, it's saying f of negative 1, and since f of x is equal to 2x squared plus, whatever that is, f of negative 1 is going to be 2 negative 1 squared plus 4 negative 1 minus 1. Later, we're going to see like g of like negative 5. It's still the same thing. You just plug in negative 5 for whatever x's are in there. And then so on and so forth. So this is going to be 2 plus minus 4 minus 1, which is, what is that, minus 3? Negative 3? Yeah. Oh, look at that. It's a little kind of weird one, but same thing. So g of a plus 1, and we have a g of x. So all this is saying is this a plus 1 replaces that x for everything in the equation. So if g of x equals 3x plus 3, that means g of a plus 1 equals 3. a plus 1 plus 3. Distribute 3, which is 3a plus 3 plus 3, which is 3a plus 6. All right. Determine the largest open intervals of the domain, increasing, decreasing, constant. You wrote it right here. If it's increasing, it's going up, decreasing, going down, constant stays the same. For these, you want to read from left to right, right? So in this case, like I guess you could imagine it's like a roller coaster, and the roller coaster is going down, and then it's going up. In this case, the roller coaster here is going down, staying the same, then going up. So on that principle, you kind of see where this is going. On this one, and these also go infinitely in their respective directions. So on here, it'd be decreasing from negative infinity all the way up until this point, which is negative 1. So this is negative infinity all the way to negative 1. And then from negative 1, it starts to increase all the way to positive infinity. So where is that? Oh, they use the curved bracket, but whatever. Increases from negative 1 to positive infinity, decreases from negative infinity to negative 1, which is what I said, but reversed. Same thing, it goes from negative infinity to, what is this, negative 3. So decreases from negative infinity to negative 3. Then from negative 3 to 3, it's constant. And then from this 3 all the way to infinity, it increases. So 3 to infinity, increase, decreasing from negative. Yep, okay. That one. Graph the linear function to give the domain a range. Domain, again, x, range, y. Okay, so f of x is kind of a weird way of saying y. So in this case, it's saying y equals 1/3 x plus 1. This is slope-intercept form, right? This is same thing as saying y equals mx plus b. M is slope, b is y-intercept, or wherever the line crosses this axis. So in this case, our slope is 1/3, right? Rise over run. So rise is 1, goes over 3, so it goes up 1 over 3. And our intercept is positive 1. So let's start from there. Y-intercept is positive 1. And it goes up 1 over 1, 2, 3. Up 1 over 1, 2, 3. Down 1 over 1, 2, 3. And then you just keep going. The range, the domain and range for this one, well, it goes infinitely right and infinitely left. So the domain is negative and positive infinity. And it goes infinitely up and infinitely down. So the range is also negative and positive infinity. Is it constant? No. Well, depends, but I don't know what to tell you there. What'd you write? I don't think it's constant. I think constant has to be a flat line. Where is it? You didn't write it. Okay, well, whatever. It has to be flat or vertical. I think if that was constant. So for this one, if you have a line that's given to you like that, if it's like x equals -2, you find where x equals -2 and you just draw a line through that and a straight line down. If it was y equals -4, same thing, you find -4 on the y-axis and you draw a straight line through it. This one's x equals 4. You already did that. Crap. draw a straight line through draw a straight line through 4, and the domain, it doesn't go anywhere in the x, or it doesn't go anywhere right or left, so the domain is stuck at 4. So you could just put like d equals 4, I guess. And then the range is, it goes infinitely up, infinitely down, so the range is, I guess I could write it, out, right? Range is negative infinity, positive infinity. Is it constant? I think so, because it's constantly, it's not changing like this one where it's like there's like an incline. This is just straight. It's straight. It's straight. Don't worry about it. Find the slope of the line satisfying the given conditions through 1, -2, 6, -5. So same thing. This is asking you for the slope, or m. I don't know why these are blank. So this is point 1. So x1, y1, x2, y2. It's going to be rise over run. Rum, okay. Which is the same thing as saying m, which is, again, slope. You plug this into there, so it's going to be -5 minus the -2. 6 minus 1. So this can be positive, so it's going to be -3 over 5, which is this one. Look at that, rise over run. Find the slope of the line and sketch the graph. So this is y minus 5 equals 0. Solve for y, you get y equals 5, which is what I said earlier. You find 5 on the y-intercept, draw a straight line. That's pretty much it. The slope here would be 0, because slope is, it's a slope, like a ski hill. If a hill was flat, there'd be no slope. This is flat, or this is flat, so there's no slope here. Similarly, if it was a straight line up, the slope would be infinite because it's a straight line up. I mean, it'd be like a roller coaster going straight down. The slope is essentially infinite in that case. There's no angle of like decline. It's just okay. All right. So yeah, in this case, the slope of the line would be 0 because it's flat. Write an equation for the line described given the slope-intercept form. So slope-intercept form is y equals mx plus b. I see daylight now. And they give you m, which is 3. So it's going to be y equals 3x plus b. And then they also give you 2 coordinate points, which again is x and y. And we need to find b. So what we can do is we could plug in this x and y and then find b. So y is -5. X is 8. This is going to be equal to, if you solve for it, it's b equals -29. Which then you could just plug that b back into there to get slope-intercept form, which is y equals 3x minus 29. Which is this one. The graph of the linear function f is shown. Write the equation that defines x. Write the equation in slope-intercept form. Again, slope-intercept form, y equals mx plus b. M is rise over run. It's the slope. And b is the y-intercept, where it crosses, or where the line crosses the y-intercept. So this is the line we're given. And as you can see, the line crosses the y-intercept form at this -4. So we already know b is -4. M is, we could do 2 things. We could either pick 2 points and do y2 minus y1 over x2 minus x1, and then solve that to get m. Or you could kind of just caveman it and see where is there a good point here. so at 2 and 6 right here, or negative 2 and 6, there's a decent point on the line, so you could kind of caveman that. So it'd be up to, or okay, or I want, be purple. It'd be up to 1, 2 over 1, 2, 3, 4, 5, 6. So it rises 2, goes over 6. So this is M, but also 2 over 6 is the same thing as saying 1/3, which that up 1 over 1, 2, 3, up 1 over 1, 2, 3 gives you the same place. So use the smaller number 1/3. Usually when you're cavemanning it, or even when you're picking 2 points, you want a point that lies on the line that's a really good one. Because you could pick something like this one, right? So this would be -5, but this would also be like 2.5, which is a bad point because it doesn't really help you. So pick a one that's like on a whole number and a whole number when you're either using this method or the caveman method where you're just hopping up 1 over 2, up 1 over 2, you know? Anyway, so we found M to be 1/3 and B to be -4, which y equals mx plus b, so it'd be that one. Write the equation for the line described perpendicular to -2x plus y equals 4. Okay, so first things first, let's make this into y-intercept form. So that's going to be y equals 2x plus 4. These are the same thing. To get a slope perpendicular to that, we want to take the reciprocal of the slope and then make it negative, or multiply by -1. Let me say that. So the reciprocal of 2 is 1/2, and a multiply by -1 is going to be -1/2. So, and we could see this in play. So if I did 2x plus 4, remember, okay, hold on. And then if I take the reciprocal, so -1/2, this is the reciprocal. It's the line that's 90 degree of the line we originally have. If you want another idea, reciprocal, think of like the kitchen floor and then the wall. So this is the kitchen floor, and this would be the wall. The wall is perpendicular to the floor. And then if I had like an equation like y equals -7/3 x, right? If I want a line perpendicular to that one, it'd be y equals 3/7x, right? Because I take the reciprocal of this, which is 3/7, and I multiply by -1, which is negative times negative is positive, so you get that. Okay. So I take the reciprocal of this and multiply by -1, so it's -1/2 x. And then you might ask, like, what about the plus 4? You can add that. It's still perpendicular to it, but they give you another caveat, which is a line perpendicular to it that also passes through 2, 5. So we need a specific line. So this slope still works, but we need a specific y-intercept now. So we plus b. But guess what? They gave you an x and a y coordinate that you're able to plug into here and here. So let's do that. So it's going to be 5 equals -1/2 2 plus b. This is going to be, what is this? 5 equals -1 plus b. B equals 6. So then you're able to plug that into there. Y equals -1/2 x plus 6. That would be your final answer, which is, of course, this one. Find the slope and the y-intercept of the line. This one, all you have to do is algebra and solve for y. So it's 3x minus 4y equals 4. Okay, so 3x minus 4y equals negative 4. And then solve for y. Bring the 3x on the other side. It's going to be negative 4y equals negative 4 minus 3x. And then we want to take this negative 4 and put it on that side. So we divide both sides by negative 4. So it's going to be y equals negative 4 over negative 4 minus 3x over negative 4. Y equals negative 4 over negative 4 is just 1. So 1 minus, let's say, how do I want to say this? Right. Because this minus here, make it positive. There you go. And then you could just kind of flop these two. So you get y equals 3 over 4x plus 1. So this is the slope, 3/4 right here. So, I mean, it can't be the rest anyway. But the intercept is also at this one right here, right there. Well, I guess you would have to plug in. Oh, I mean, just go off this, right? But if you want to double check, you could plug in 0 for x and see what you get. Okay. Okay. So remember when I said x squared is this graph and y squared is this graph? Okay, remember that. So this one has to be y squared already. This one's another popular graph. It's the y equals root x. Oddly enough, not to be confused with that one. But when it's root x, it's just that. There's no bottom part to it. So this one's root x. And then leaving you, I'm going to ask you which one's root x. Leaving you left with y equals x cubed. Y equals x cubed. If you want to know, if you see a graph make 2 turns, so it makes 1 turn here and 1 turn here, that means its exponent has to be cubed. If it makes 3 turns, so 1, 2, 3, then the exponent's to the 4th. If it makes 4 turns, it's to the 5th, yada, yada, yada. Whatever. Right? Here it makes 1 turn, so the power has to be 2. This one makes 2 turns, so the power has to be 3. I mean, whatever. Okay. Which one of the graph is y equals root x? That's graph C. We don't even need the rest of the question. Which one is x cubed? It's graph A. We don't even need the rest of the question. Which is not a graph of a function. If you do the vertical line test and it passes through 2 points, then it's not a function. This passes, this does not pass. It's graph B. Doesn't even need to look at the rest of the question. I think that is the whole question, whatever. Find the requested value. This one may look hard, but it's just asking you, where does this number fit, and then plug it in, right? So again, it's f of x. It's essentially replacing the x here with -3, right? So I guess you could say it's x equals -3. And then these statements are saying if x is less than 3, use this equation. If x is in between 3 and 8, use this equation. And if x is greater than 8, use this equation. All right? And so this is saying x is equal to -3. So we're going to be using this equation. Right? Because if x is less than 3, use this one. So we're going to be using that one. All right. So f of x is equal to 4x plus 1. And remember, this is saying x, replace the x's with -3. So f of -3 is the same thing as 4 -3 plus 1. This is going to be equal to -11. Okay. Graph the function. Remember, f of x is like kind of a weird way of saying y. If it makes it easier for you. So this is saying when x is greater than or equal to 1, f of x is equal to -3, or in other words, y is equal to -3. So which one has y equal to -3 when x is greater than or equal to 1? It's this one or this one. So it can't be A. And then, well, I guess these are both the same, except for the black dots. If you want to just speed run this one, the black dot means it touches, right? The white dot means it doesn't touch. It approaches but never touches. And so if you have this underline right here, that means it touches. So that means the -3 right here, it touches. We have the underline there. So it'd be B. But if you want to, if you want to just keep doing this, this one's saying, let me draw my own graph here. When x is greater than or equal to 1, y is equal to -3. So it's like right here, -3. And then when x is less than 1, so there's going to be like a skip right here because it can't be 1. X or y is equal to -1 minus x, which is y-intercept form for -x minus 1, which m in this case would be -1, b would be -1, so it'd look like something like this, which is, again, the same thing here and here. The only difference is that there's a black dot here and there's a black dot here. And if there's an underline on this one, then the black dot has to be on this one. Okay. For God's sakes. I could be brown, I could be blue, I could be violet sky. What time is it? Oh. Ignore that. Describe how the graph of the equation relates to the graph of y equals x squared. Again, y equals x squared is the famous one that's pointing up this way. The other one is y squared, which it's like if this one fell over to the right. This one's saying describe how it relates to the y equals x squared. Okay, so it's saying how does this equation differ from the original one we just saw? And so using this little note I have inside, x minus a squared plus b. A are the steps horizontally, right? However it moves right or left. If a is negative, it moves right. If it's positive, it moves left. B is how the graph moves vertically. If it's positive, it moves up. If it's negative, it moves down. We'll worry about this one in a second. So applying what I just said to the x minus a squared plus b. How does it relate to this one? A is, I guess, all right, whatever. A is, actually, I should make it positive here. A is -2, so it's going to move to the right. B doesn't exist, it's 0, so it doesn't move up at all. And that's pretty much it. The translation 2 units to the right here. And if you want to see it, it's going to be looking like x minus 2 squared, which you could see right here, the original is black and the new one's red, and it moves to the right 2 units. If you apply the same one again, x plus a squared plus b, a is 0, so it's x squared plus b, and b is positive. So if b is positive, it moves up. A translation 5 units up. So x squared plus 5, we can see it right here. Or I can just move it on here. The original is right there. If I move it plus 5, it goes up a little bit. It goes up 5 units. Let me zoom in actually. Right here. So this is 0 and that's at 5. If I take away that one, it's at the origin. If I add 5, it goes up 5. 6x squared. Okay, so this is where we get into this one. So a coefficient is a number before something, in this case a variable. So it's the number before our variable x squared. All right, so if the coefficient, in this case 6, if it's greater than 1, it stretches, and if it's less than 1, it shrinks, right? So if I had a coefficient of like 1/2, it would shrink. If it was something like 20, it would stretch, right? So in this case, the coefficient in front of x squared is greater than 1, so it's going to be a vertical stretch by a factor of 6. It doesn't move, it stretches, so it can't be translations, and it's not horizontal stretch, it's a vertical stretch. If you want to see it, it's going to stretch, it's going to get skinnier essentially. So this is the original. If I put a 6 in front, it's going to stretch upward, but it's going to get a little skinnier. Okay, and if you want to apply the x plus a squared plus b, a doesn't exist, b doesn't exist, and then the coefficient would go like right here, but whatever. Okay, so then x plus a squared plus b, a doesn't exist, there's a coefficient, so we know it's going to stretch or shrink, and b is -5, right, because it's outside of the square root, or the outside of the squaring, the exponent, let me say that, outside of the exponent, so it's b. So b is negative, so we know it's going to translate downward 5, and 1/5 is less than 1, so we know it's going to shrink. So which one has 5 units down and shrink? It's going to be D. So a translation 5 units down and a shrinking by 1/5. And then again, x plus a squared plus b. Again, if a is negative, it goes to the right. If it's positive, it goes left. If b is positive, it goes up. If b is negative, it goes down. So a is -8. So it's going to move right 8. And b is positive, so it's going to move up 5, which is this one. Oh, this is another long one. So to determine if a graph is symmetric with the y-axis, x-axis, or origin, you have to do 3 things separately. To see if it's x-axis symmetric, you replace the y with a negative, and if the equation stays the same as the original, it's x-axis symmetric. For y-axis symmetry, if you replace the x with a negative and the equation stays the same, it's y-axis symmetric. And then for origin symmetric, is you replace both x and y with a negative number, and the equation stays the same at the end. It is origin symmetric. So I'll use purple for x-axis, I'll use blue for y, and I'll use red for origin. Okay, so for, what did I say? For x-axis symmetry, we're tested right now, we replace the y with the negative y. So there's going to be negative y equals 3x squared plus 1. Distribute the negatives. It's going to be y equals negative 3x squared minus 1. All right. Is that the same as the original? No. There's a negative. There's negative here and here that doesn't exist here or here. So it's not the same. So that means it is not x-axis symmetric. So I'll put it like an x, I guess. I don't know. Or like a, there we go. Or better yet, I'll do this. Okay. For y-axis symmetry, we replace the x's with negatives. So y equals 3 negative x squared plus 1. Y equals, if this is an even exponent, then the negative x goes away. So it's going to be 3x squared plus 1, which is the same as the original. So this is, what did I say? Y-axis symmetric, and then we could check if it's origin symmetric. So you place both the y and the x's with negatives, so it's going to be negative 3, negative x squared. Was it plus 1? Yeah. So it's negative 3y. This is a square, so the negative goes away. Or this is even, so negative goes away. So plus 1, distribute the negative. Which is not the same as that, so this is not origin. So the only one it is y-axis only, so it's going to be A. All right, let's do the same thing for this one. Oh my god. Okay. Let me make it a bit smaller. Oh my god, that's huge. Okay. So again, we're going to replace the y with the negative to see if it's x-axis symmetric. So it's going to be negative y equals negative 8x to the 5th plus 3x to the 3rd. Distribute the negative 1, so it's going to be positive 8x to the 5th, negative 3x cubed. Is that the same? Is that the same as this? It is not, so frowny face. Time to check for the blue one, or y-axis symmetry. Again, replace all the x's with negative. So it's going to be y negative 8 negative x to the 5th plus 3 negative x to the 3rd. And then since the exponent is odd, we can bring out the negative in front. So it's going to be y positive 8, because negative times negative is positive, x to the 5th. This is an odd exponent, so we're able to bring exponent in front. So it's going to be negative 3x cubed. Is this the same as the original? It is not. So it is also not y-axis symmetric. So let's check if it's origin symmetric, which is going to be both y and x are negative. Negative equals... right? And then we're able to bring this negative out in front because these are both odd exponents. So it's going to be negative y equals 8x to the fifth minus 3x to the third. And then there's a negative here we could distribute, which becomes y equals negative 8x to the fifth plus 3x cubed, which is the same as our original, so it is origin only. Smiley face. Oh, bruh. Okay. Alright, similarly to that one, to check if it's odd, even, or neither, all you have to do is change this all these x's with a negative x, and if the equation stays the same, it's even. If the equation is the same, but it's the same, let me say it this way. If you make them all, change all the x's with negative x's, and the equation is the same but negative, right? So essentially like the opposite, like all the signs are flipped. So this would be positive, this would be negative. Then it's odd. And if you change all the x's with negative x's and it's a mix, but it's not the same, then it is neither, right? So if this was positive, this one's negative, it's a mix of it all. Oh, wait. No. If this was positive, negative, this would be odd because it's a flip. But if this was positive, negative, positive, that'd be neither because it's not the same, which would be even, and it's not flipped because it would be odd. If that makes any sense. Let's just go through it. So again, even if you replace all the x's with negative x's and it stays the same, then it's even. So let's do this one. So this one would be negative x to the fourth minus 5x squared minus 3. If it's an even exponent, the negative goes away. So it's just going to be x to the fourth minus 5x squared minus 3. Oh, there should be a negative in here. But it goes away anyway because it's an even exponent, which is the exact same as this. Since it stays the same, it is even. For this one, it's going to be negative 5, negative x cubed plus 4 negative x. This is an odd exponent, so you're able to bring this outside, which is negative times negative is positive, 5x cubed. And then this is going to be minus 4x, right? Because plus 4 times the negative x is negative 4x. So 4 minus 4x is just this. But which is the opposite, right? Because this is negative positive, and now it's positive negative. So it's the opposite, therefore it's going to be odd. All right, and then for this last one, let me just say, if it's negative, negative, positive, it's even, all right? If it's positive, positive, negative, it's odd. And then anything else, it's going to be neither. So let's do this. So negative 4, negative x to the fourth, minus 4, negative x, plus 2. Even exponent, this goes away. So it's going to be negative 4x to the fourth. Technically, this is an odd exponent because it's to the 1. So you could say that goes out, but I mean, negative 4 times a negative x is positive 4x, so it doesn't really matter anyway. Bam. So now we're left with a negative, positive, positive. So it doesn't match the odd one, it doesn't match the even one, so it has to be neither. Right? Because I'm looking at the This one, like, I'm looking at specifically these. Okay, I don't have to erase it. What am I doing? Okay. Find f plus g of -5 when f of x is that, g of x. Okay. I don't like how they write this, but whatever. It's the same way of saying this. So, I mean, let's just write it like that, right? X of -5 plus f of, oh wait, plus g of -5. And then remember, when you have this -5, it's just essentially saying replace this -5 with all the x's in this equation, right? So if I replace this x with a -5, it's going to be -5 plus 4, which is -1, right? Same thing with this. It's saying if I replace this -5 here, so this is going to be -5 here, -5 here. So it's going to be -5 plus 1, which is -4. And then, again, it's just saying that, which we know f of -5 is -1. So you can put this here, -1. And we know g of -5 is -4. So -4 minus 1, -1 plus a -4 is -5. Right there. This one, again, it's saying that, but I'll just write on the side. It's saying f of -4, g of -4. All right. And then let's just focus on doing these first, and then we can just plug it back in when we get normal numbers. All right. So f of -4 is equal to 3 of -4 minus 3. Right, same equation here, but we're just replacing the x with -4. This is -12 minus 3, it's -15. G of -4, this is a kind of a mean one they're doing, is going to be 4, -4 squared, plus 14, -4, plus 5. Oh, wait, what? Oh, I guess it'd be minus, yeah. All right. It'd be this, actually. Right, 13. This would be 64. This would be, I already forgot, what it was, like 59, some shit like that. 56. All right. This is minus 56 plus 5, which that equals 13. Right? And then we could just plug this f of -4 back into here, and this g of -4 back here, so you get -15 over 13, which is this answer. Okay. So that's with numbers. Now, what if they don't give us numbers and they just give an x? It's the same principle. So this is the same way of saying f of x minus g of x. We know f of x is this, so just plug that in. So f of x is 9x minus 6 minus, I'll use red this time, right? Separate it. G of x, we know is 3x minus 3, so we can plug that in. 3x minus 3. Distribute this negative, so it's going to be, I'm just going to use blue now, 9x minus 6. 6, there we go. Minus 3x plus 3. add like terms. So 9x minus 3x is 6x. Negative 6 plus 3 is negative 3, which is this one. Find the domain of f plus g when blah, blah, blah. All right. And then just remember, it's the same thing as saying f of x plus g of x, which they give us f of x as that, which is, so it's 2x plus, or 2x minus 7. And g of x is 1 over x. All right. So that'd be what it, if we were just doing this problem again, that's where it would stop. But we gotta find the domain. Okay, so again, the domain, oh no, I don't want that, I want that, is where it, domain's the x-axis, and for the x-axis, or like the range of the, I can't say range, for the length of the domain, we don't want a negative in the square root, right? It can't be a negative number. So again, if we just take this part out, the lowest number it could be is 0, so let's set it equal to 0. And if you solve for 0, or if you solve for x, you get 7/2, right? So anything would it be higher? No, anything lower than 7/2, we get a negative number, right? 7/2 is, if you want to know, is 3.5. So if I put, so what's lower than 3.5? 3, right? So if I put in 3 here, this is going to be 6 minus 7. That's going to be negative 1. I can't have that. So the number, it has to be higher than 7/2, or 3.5. And it has to be higher than positive 7/2. So you could immediately, you could take that out. You could take that out. You could take that out. Oh shit, look at that. That's the domain of this one. Find the requested function value. I think these are the last 3. These look a little hard. I don't know why they use the degree symbol here, but whatever. This is like a combination, a little bit, but it's pretty much saying g of f of x. What does that mean? So it's saying g, big parentheses, let me use red, f of 37. Okay, so what does that mean? So it's saying solve this first, right? So whatever number you get from this, whatever number, and then whatever number you get here, that's going to be your g of x. So I think it'd be better if I just show you. So I'll do this part in red and then go from there. So let's just pretend that g of x doesn't exist, and we're just focusing on this f of 37. So f of 37, you plug in this 37 to this x right here. So f of 37 is 37 minus 7 over 6, which is 30 over 6, which is 5. So f of 37 is equal to 5. Look at that. We can plug that back in. So now it's going to be g of 5, right? Because f of 37 equals 5, so that means I could replace this f of 37 with a 5. So now it's saying g of 5, look at that. Oh, I covered this up. I think that's a 7 though. G of x equals 7x plus 2. I just got to replace the x with a 5 now. So 7, 5 plus 2, which is 37 times 5 is 37, or 35. 35 plus 2 is 37. So the answer is 37. It's a coincidence that it's the same number as the one they give you. Don't look into it. Yeah. I think that's the only one they actually use numbers for. But again, if they give you like the of, then you solve for the one in the center first, and whatever number you get from there, then you just do the same thing and you plug it back into the bigger one, right? The one that's eating the smaller one, I suppose, is a way to think about it. Let me clean this up real quick so I can write it a little better. How I would personally write it is right here, is that bracket, but so I guess our f of 37 equals 37 minus 7 over 6, which is 5. So G f of 37 is equal to G of 5, which is equal to 7, 5 plus 2. Again, the 37 is a coincidence, but if you want to see like a complete longer version of it, I guess this is how you would write that, but whatever. And then I'll circle it. There you go. 37, that's a 37. This one doesn't use numbers, it's just combining like terms. So again, it's using f of g of x. So in this case, now f is the bigger one, g is the smaller one. Nothing got to plug in. G of x is 3x minus 1. So it's saying f of 3x minus 1. Because g of x is 3x minus 1. Just plug that in there. Because it's the same as that. And then f of x is 4x plus 7 right here. So you plug in this 3x plus 1 into that x. So this is going to be 4x plus 7. Place the x with 3x plus 1, or 3x minus 1. Distribute the 4, so you get 12x minus 4 plus 7, which is 12x plus 3. Right there. And then same thing again. But now g is the bigger one. And you wrote it right here too. You can see that one. It's going to be g of f of x. F of x here is negative 5x plus 9. So you can replace this f of x with that. So it's going to be g, I already forgot it, negative 5x plus 9. Negative 5x plus 9. And now this is saying replace the x in this one with negative 5x plus 9. So it's going to be 6x plus 9. But replace the x with negative 5x plus 9. Blah, blah. Right? Because we're replacing this with this x right here. So that's where this comes from. And then if you distribute this out, it comes negative 30x plus 54 plus 9, which is negative 30x plus 63. And that is it.